Welcome to a lesson on cylindrical surfaces. The goals of this video are to define a cylindrical surface and also to graph a cylindrical surface. A cylindrical surface is a surface that is traced by a line moving parallel to a given fixed line and intersecting a given curve. We'll take a look at what this means in just a minute. The curve is called the generating curve or the directrix, and the set of parallel lines are called the rulings. A couple things to remember about a cylindrical surface. The curve is in the plane containing the two variables in the equation, and the rulings or set of parallel lines are parallel to the axis of the missing variable. And that's really important to remember. And then any equation in three variables that's missing one of the variables will be a cylindrical surface. Let's take a look at a couple of examples. Here we see the graph of z equals x squared. So if we take a look at just the graph of this in the xz plane, it would look like this parabola as we see here. However, if we graph this using the xyz coordinate system, it would become a three-dimensional surface. So again, the red curve here in the xz plane would be our generating curve. And then the surface is generated by the set of parallel lines that intersects this curve. So if we turn this sideways to look at the YZ plane, we would have an infinite number of parallel lines here called the rulings. And the rulings on this graph would look something like this. And all of these lines would generate the surface. If we take a look at this using Maple, here's the surface, and if we drag and move this around, you get a better idea of what this surface looks like. Now I should mention, most people think of a cylinder as a circular cylinder, but using this mathematical definition, a cylinder is not what you might have expected. Let's take a look at one more before we graph our own. Here we have the graph of z equals cosine y. So looking at the graph of this just in the yz plane, we have this red graph. And then if we graph this in the xyz coordinate system, it becomes this three-dimensional surface. And again, the generating curve is this red curve as we see here in the xy plane. And the rulings would be the set of parallel lines as we see here in the xz plane that intersect this generating curve, and they would look something like this. And these lines actually make up the entire surface, or this cylindrical surface. Again, let's take a look at this using Maple. Here's the graph of the surface. If we angle it this way, you see the generating curve, and all of the rulings would be all the lines moving in this direction from left to right, which create this cylindrical surface. Okay, so let's go ahead and take a look at a couple of our own examples now. Here we want to graph x squared plus y squared equals 16. Because the equation contains x and y, that means the generating curve will be in the xy plane, and since the equation does not contain z, the rulings would be parallel to the z-axis, which means the rulings, or the set of parallel lines, will run up and down. Well, if we were to take a look at the graph just in the xy plane, we should be able to recognize this as a circle with the center at the origin and radius of 4. So it would look something like this. If we were to sketch this on the xyz coordinate system, the x and y intercepts would be positive 4 and negative 4. So let's go ahead and plot those. So this would be the generating curve, and all the rulings would be the lines moving up and down that intersect this curve. To give this a three-dimensional perspective, Let's go ahead and graph another circle that's a little bit higher, maybe something like this. Let's go ahead and make a cylinder out of this. And then again, if we were to sketch the rulings, they would be all of the lines that run up and down intersecting this generating curve parallel to the z-axis. Let's take a look at another graph of this. Here's our circular cylinder. Again, if we rotate this down, you can see the generating curve. Rotate this back up, all of the lines running up and down along the cylinder would be the rulings. Let's take a look at one more. Here we want to graph the cylindrical surface y equals x squared. So the generating curve will be in the xy plane. We should be familiar with this graph in the xy plane. When x is 1, y is 1. When x is 2, y is 4. It's symmetrical across the y-axis, so it would look something like this. So again, this would be the generating curve. Let's go ahead and sketch this in the XYZ coordinate system. Notice this graph does hug the positive y-axis. So to sketch this, we have a point at the origin. Here's the y-axis. So the parabola is going to open in this direction here. Let's go and just plot a couple points here. When x is 2, y is 4. That would be here. And when x is negative 2, y is also 4. So the parabola in the xy plane would look something like this, which is our generating curve. Notice the equation does not have z, so all the rulings again will move up and down parallel to the z-axis. To give this a three-dimensional perspective, we'll go ahead and copy and paste this curve higher up along the z-axis. Something like this, and we'll go ahead and connect the corresponding points. Looks something like this. And again, if we were to sketch the rulings would run parallel to the z-axis like this. Again, let's go ahead and take a look at this using Maple. Again, here's a graph of y equals x squared. If we rotate this around, you get a nice perspective of this in space. Okay, that's going to do it for this video. I hope you found these examples helpful. Thank you for watching.